So, today is the lecture, the first lecture of this class, this course, and the title of the lecture is Electric Energy Systems, a Perspective. All of you know that electric energy is an essential ingredient for anything what you want to do, any industrial activity, all round development of any country, any society, because whatever you may do since morning to the evening, you practically consume electric energy, be it geyser, the water heating in winter for taking bath, or a breakfast, toaster, or anything, the cleaning of the house, you need vacuum cleaner, any industry, lighting, commercial activity. So, we need electric energy. Even your computers, without electric energy, no computer can work for all time. How much UPS will help you? So, then we need to generate electric energy in bulk. After generation, you have to transmit it also, because as you know, the load need not be close to the generating station, and transmit economically, because anything, whatever you may say, cost remains a main factor in any activity, and we may have to transmit over long distances. It so happens the coal or any fuel need not be available close to the load. For example, in UP, the generation is in eastern UP and the load is in western UP, the industries are in western UP. So, but the generation is in Singrauli, the first superthermal station in India. So, you have to transmit power over long distances. The electric energy, the beauty is it can be adapted easily and efficiently to domestic and industrial applications. For example, lighting, just you have to put the switch on, unlike other means, say maybe a candle, maybe a kerosene lamp, you have to do a lot of effort. Mechanical work, drives, just to start the motor. The per capita energy consumption is a very reliable indicator of any country, how much progress it has done. There are other indicators. For example, how many people own telephones, how many people own cars, how many people have their houses of their own. Australia is number 1 in this category. 2/3 of the Australians own their own houses. Our tele-density was very bad till about 10-15 years back. Even today, only in urban areas it is 3.6, in rural it continues to be 0.5. Thanks to the revolution of mobile phones, etc., now it is very easy to talk to anybody. Now, today we are of course talking about electric energy, so we will restrict ourselves to the electric energy. Now, how do you say the per capita energy consumption is a reliable indicator? If you have no activity, if you have no industry, you do not need electric energy. Unfortunately or fortunately, our population is so large, we are only second to China, second largest populous countries in the world. We have already crossed 100 crore mark in 2000 AD, and we are likely to overtake China by 2020. Now, because of that, our per capita energy consumption comes to just 425 kilowatt hour. How about UK? 5600, Australia 4000, Hong Kong 4000, US 13,000, and the highest in the world is Norway and Sweden, about 17,000. As I said, we try to blame population for whatever is wrong in this country, because it is so easy, it is so visible, but that is not correct. If you look at China, which I just said is a higher population, their per capita energy consumption is higher than us, 500. Only perhaps Bangladesh is lower than us in the world. Now we come to conventional sources. Conversion from fossil fuels, that is coal, oil, natural gas, these are the three main fuel which can be used, which can be burnt to produce heat energy, which can later on be converted into mechanical energy and subsequently electric energy. So, there are two conversions involved in any conventional way of generation of power. All of you must know any number of conversions efficiency goes down. We have been taught in our earlier stages of our life that eta is equal to eta 1 into eta 2. In that case, eta will be lower of the 2. The value of total efficiency will be lower of the eta 1 or eta 2. Now, we can have a nuclear power, we can have hydro resources. These three are basically the conventional way of generating power in the world. And the fact remains, even by 2020, the total power generation in the world will be 80% by conventional energy only, but renewable energy will take 20% of the total generation, which is a very good percentage. Today in 2003, it has not crossed even 5% mark. In India, it is hardly varies from 2 to 3%. As I just said, heat energy by burning fossil fuel or fission of nuclear material, fusion still belongs to the realm of theoretical studies. It is the delight of theoreticians. You can only produce papers on fusion. There is no, in practice so far fusion is not been a success. Though for your information, let me tell you, in 1989 the Time magazine published in US in April issue carried a news item that 2 American scientists were successful in producing a fusion. Later on it proved to be a cold one, just like our Ramar Pillai, who claimed that we can produce petrol from water. But one day, who knows, as I was telling you earlier on, that it will be a reality, or once it is a reality, there will be no need of, no dearth of electric energy, no energy conservation will be required, no energy management will be required. But let us see when that day comes. Now, heat energy is converted to mechanical form through a thermocycle. Those of you who are mechanical engineers, you know what is a thermocycle. Carnot cycle, Rankine cycle. You must, even electrical engineers do read certain courses in mechanical engineering. And then mechanical engineering, mechanical energy to electric energy through generators. Now, thermocycle, as all of you know, is a low efficiency cycle, 1 minus T2 upon T1, that is efficiency, and efficiency is normally less than 40%. In India, the highest may reach 30%. The best maintained government plant is in Vijayawada, and the private plants are Birlas in Renukoot and Tatas in Bombay. In fact, Bombay has not experienced any shortages, any outages, any blackouts, brownouts, thanks to the private companies. As you know, the partly Delhi is also in the hands of Tatas now, and let us hope things will improve further. Now, conventional sources, though I just now said 80% in 2020, we can't go on and on using conventional energy sources forever, because they are limited. When I was a student in 60s, my teachers used to tell me the coal is there for another 200 years. Today, I also tell you that coal is there for 200 years. Why I am able to tell that? Because we always we explore newer and newer places where you get coal, but that does not mean you should burn all the available coal. Why? These two things are entirely different, availability and affordability. The Mercedes car is available in the market. Can we afford it? Can all of us afford it? Very hopeless minority of Indians can afford it. So, though coal may be available for 200 years, we cannot afford to burn it. And as you all know, our Indian ethos, we leave things for our future generation. Why do we have provident fund? Why do we have pension scheme? If you ask anyone why you are building house, oh, for children. So, why can't you leave your coal also for your children and children's children? So, that is why there is a need to conserve, economize, minimize on burning of coal, and hence we need to take the help of other sources of energy which are perennial, that is renewable, the green energy, the natural energy, the new energy sources. There are, it is not only the availability, it is a question of environmental and ecological considerations, and that is why energy and environment we talk in the same breath. You may be having couple of courses in environmental engineering in energy studies MTech program. Let me take back you to 70s. In fact, till 70 there were no problem of any electric energy throughout the world. The 70s saw 3 steep rises in oil prices, and that was really shook the world, and it was a wake up alarm, and people started shifting from oil to coal. In fact, as far as we are concerned in India, we have no choice. Our indigenous oil production is only 40% of our requirement. And then secondly, do not think that all oil and coal is only for power production. There are so many other things which we do with the coal and the oil. Coal is still being used in many Indian homes for cooking. Coal is still being used in steam engines, though in a very, very limited way now, for shuttling services, or few trains like Palace on Wheels. They want to retain that old flavor and glamour and so on. What is important today? On one hand, I said we should increase our per capita energy consumption, because that will show the world how much progress we have done. Please remember, our President Dr. Kalam says that by 2020 we should be a developed country, and if that dream has to be converted into reality, naturally we have to generate energy and we have to use energy, so that our per capita energy consumption goes up. As I said, that is one indicator of your prosperity. However, when I write here curtailment of energy consumption means what? We are talking for the whole world. The developed world has already reached a level beyond which they cannot afford to consume energy. It is already maximum, because whatever they do in life, they consume electric energy, and so beyond that what else they can do, and they will have to learn to curtail. In fact, in Sweden, as soon as the energy consumption of a particular house goes beyond a limit, the rate becomes double. The housewife runs throughout the house and starts closing various switches, so that there is no wastage of energy, and it comes back within that zone where the cost of energy is a normal one and not a panel one, not a double one. So, the developed world has to reduce the energy consumption, the developing world has to increase. As is the well known proverb, someone's food is poison for somebody else. So, what prescription is good for developed world is not necessarily good for developing world. That does not mean that you have got a sanction of wastage of energy. We still have to conserve energy. Using the experience of the first world, that is the developed world, we should not try to raise it so much that you have to further reduce it. It should be sustainable. Now, sustainable word is being used everywhere in any title of the thesis project, sustainable development. Everybody is now talking of sustainable development, whether it is a country's development, whether it is institute's development or department's development or your own development. Obsolete technology have to be discarded. You should not go through the same bad experience by which the US or any other developed country has gone. So, you should learn lessons from others, in brief. If someone has gone from some route and there is a problem on that route, he will warn the other people, hey, do not go that way, there is a problem there. So, he is merely transferring his experience to somebody else, so that he does not have to unnecessarily go through the same bad experience, right. So, we should learn, we should keep our eyes and ears open and see what has gone wrong there. For example, we should learn from Chernobyl accident, from 3 Mile Island accident, nuclear accidents I am talking. 3 Mile Island was in 70s, the Chernobyl was in again 80s, mid 80s. So, we should be, we may have a nuclear power, we do have a nuclear power generation, but guard against those factors which led to those 2 accidents as far as possible. We have to intensify the efforts to develop alternate sources of energy. That is what your mandate is. That is why you are doing an MTech in energy studies. Most of the courses are on renewable energy. Why? Because we have to slowly but surely replace the need of conventional power generation by non-conventional sources. Why? They are sustainable, they are perennial sources. Wind, nobody will ask you money if wind is blowing. No government can tax, hey, you are enjoying free breeze of air, give me 2 rupees. Or sunlight you are getting, it is free. Nobody can charge you for getting sunlight in your house if you have properly built the house. Solar, tidal, wind, biomass, waste, sea, MHD, geothermal and so on. We just talked few minutes back about fusion energy, which is futuristic, but once successful, it will give you inexhaustible source of energy. Today, solar we are looking towards for meeting our rising energy needs. Our needs are rising. I remember I did not purchase the fridge till I was 42. Today, the boy gets job later, he gets fridge first, because the times have changed. We did not have television till I was 35. Now, the 3-year boy also or girl also watches television. If you switch it off, he or she will make her annoyance felt by the parents. So, there is that addiction is there right from the birth almost, because the mother is watching, so the child is also watching. Recycling of nuclear waste, anything, this is an era of recycling. In fact, the waste has become a primary source and the new material has become a secondary source. In fact, waste management has become a very important course. There are a couple of universities who have started MTech in waste management, because let us not throw waste anymore. The waste is no more a waste, it is a valuable resource. In fact, in foreign countries, if you want to purchase a Colgate or any toothpaste, all these are international brands. You get Colgate everywhere, Colgate Palmolive. You have to give the earlier used one tube if you want the new one. So, you can't just throw it. So, the waste, same, nuclear is no exception. We should recycle the nuclear waste, and that is why the fast breeder reactor technology has come in. And there is a research station near Madras or Chennai, a place called Kalpakkam, where we do have a nuclear power station also, right. So, why fast breeder reactor technology is becoming popular? Because you can use there this recycled fuel. Earlier, when the Nehru and Bhabha, the combined vision, the two visionaries in India, whatever Nehru did, one of the best success stories is IIT system, as you are able to see that. We just celebrated 50 years of IIT system in US, because Kharagpur IIT was started somewhere in 1951 or so. Similarly, Nehru started this industries, industrialization. Not even an Alpine was being manufactured in India before we got freedom. So, they started nuclear power station. The first station was 69, Tarapur, Trombay. Unfortunately or fortunately, the fuel used was uranium, the enriched uranium, U-232. I hope you have not forgotten your chemistry. Now, what was unfortunate part in it? It was not available in India. We had to import it. From where? From USA. And our relationship with USA was not quite good, barring Kennedy era, which was very brief. Unfortunately, he was snatched away by some terrorist. Don't think terrorist is a recent origin. Terrorism was always there. Even Ravan's act you can term as a terrorism. He is taking away Sita. What else it was? So, terrorism has been there in this world right from first day, D-Day. So, Monday, Wednesday, Friday, our relations with US were good. Tuesday, Thursday, Friday, Saturday were not good. So, whenever enriched uranium used to come, we run the plant. Whenever it was not coming, we close the shop. So, they thought, the Indian scientists thought, this is no good, this is not sustainable, to use the phrase. So, they started second nuclear power plant in Kota. Kota is the only place in India where you have all the three plants. There is a thermal power plant, there is a hydro power plant, and there is a nuclear power plant. And Kota is the only place from where at least 500 IIT entrants are coming. The big industry is there, how to help people to enter IIT. Anyway, that is not the topic of today's lecture. So, there they started using with Canadian help the heavy water, and the third Kalpakkam was totally indigenous nuclear power plant, where we used our own plutonium and thorium, and we are having the largest deposits of thorium in the world, 45,000 tons in Kerala and Orissa. Development and application of anti-pollution technologies. As I said, environment has become very, very important. You know how much hue and cry was raised in Delhi last few years, and then they had to, the Supreme Court has to intervene, and all buses were converted almost overnight to CNG. And now Delhi has become one of the cleaner cities in India. Otherwise, it was the fourth most polluted cities in the world. So, you have to develop and apply anti-pollution technologies. You can't afford to have pollution. It affects everybody, not only human beings, it affects vegetation, it affects buildings, You know, in Delhi, out of every 5 children, 2 are asthmatic. If you want to know why, just go and stand near any red light square and see that those cars, what sort of fumes are coming out, the blackish, the whitish. Please remember, white one is more harmful than black, because the combustion is not complete and CO comes out of it. So, all these anti-pollution technologies have to be studied. There has to be a course, a subject full-fledged. Bulk power generating stations are easy to control pollution, because centralized one point measures can be adopted. It is very easy. See, all of you are in the one place, it is easy to control. If all of you are standing in different places, different corners, it is not easy to monitor. So, the bulk power stations, the India thought is the best way to generate power. So, super thermal stations started, and the first super thermal station in India was Singrauli on UP-MP border. As I said, coal, we had ample coal. The coal is mostly in Bihar, the eastern part of India. So, earlier days we used to have load based power plants. Wherever load is there, we have power plant like Badarpur, Indraprasth in cities, and coal has to travel all the way from Bihar to Delhi. I remember the headlines of those days in Hindustan Times or Times of India or whichever paper you read. Badarpur coal only left for 8 hours, and there used to be panic, because 3 ministries have to coordinate: the power ministry, the steel ministry, the coal ministry, and railways, because it is the railways which were to carry this coal. Sometimes wagons are not available. So, the government of India took the consensus decision not to have any more load based power plants. So, they said, let us have the coal based power plants. That means, wherever coal is, we go there and have a big power plant. Super thermal. Super thermal means anything more than 2000 megawatt. We have many super thermal power plants: Korba, Obra, Chandrapur, Ramagundam, Singrauli, and so on, Naiveli. Okay. What was the advantage? Cost wise, it was cheaper per megawatt or per kilowatt hour generated. Cost used to come cheaper. As you know, a 100 watt bulb is cheaper than 2 60 watt bulb. There are plus and minus. 60 watt bulb you can put in 2 different places, and you can have perhaps more uniform illumination. So, there is a plus and minus in whatever you do. You must have done this lighting or illumination in your undergraduate final year or somewhere, utilization of electric power, Taylor's book or Starr's book or Pratap's book or Wadhwa's book, whichever book you might have read. So, there is a plus and minus. What is minus here? You have to carry that power generated in a jungle near those mines to load centers, because there is nobody to use that power there, barring a locality or a campus where the people who are working in that power plant are living. That may be 300 persons or 400 persons or 1000 persons, not more than that. So, most of the power has to be evacuated, transmitted, transported to far off distances. So, you need to build your transmission network, which we started with 33 kV, 66 kV, 132 kV, 220 kV, 400 kV. 400 kV came in 1970. That was a mistake. We should have gone to 500 kV then and there. Why? The power transmission is proportional to V squared, EV by x into sine delta. E and V are roughly same. So, V square x by sine power transmission. We must have done that. We will do it again in our future lectures. Since power is generated in bulk, it has to be transmitted in bulk. So, transmission line capability should be there. So, 500 kV. Now, there is a talk of having 765 kV transmission line in our country. Electric energy used today in the world is 30% of the total energy consumption. Please understand, 70% energy which we consume is non-electric form. This figure was only 20% when I was a student in 60s. It has become 10% more. Figure will further go up, rise further, thanks to one particular sector, if I want to name, is transportation. In 60s when I was studying, throughout India there was steam engines run by coal, steam. Today there is hardly any. You have to go to that Moti Bagh museum, railway museum, to see the steam locomotive, or those 2-3 trains which I mentioned earlier on in this lecture, Palace on Wheels or Shimla or Kalka to Shimla, whatever. I do not know whether that has also been converted into diesel. What is the main problem with electricity? Unlike water and gas, it cannot be stored economically. That word economically is very important, because immediately one of you can say, well sir, in the batteries form we do store electricity. There are other ways of, now electric storage has become a very important R&D topic. Compressed air storage, hydrogen, pumped storage plants, you must have heard about pumped storage plants. These are the ways in which you can store energy, but they are not. Fuel cells are coming, but they are not so economical. The first fuel cell car which has come in Japan cost 2 crores of rupees. Tomorrow it may be 2 million, but that is tomorrow, not today. Gas and water, just open a tap, you get a water. It is not that easy. So, you have to generate power as and when you need. So, the situation is more complex. Why complex? All the time you have to maintain this LG balance. What is this LG? LG is not that company, Korean company. I am talking load and generation balance. You have to constantly estimate, forecast load. So, the load forecasting has become a very important topic in power systems, in electric energy systems, even in your renewable energy. You have got to forecast how much wind power can be consumed, how much solar energy can be used, because if there are no user, why produce power? It will be a losing game. If you start a shop somewhere in jungle, there will be no customer. So, feasibility report, as you call it in industry. Before you start an industry, you have to get a consultant who will prepare a feasibility report, because after all you are opening industry to earn profit, it is not a charity. So, LG balance has got to be maintained all the time. LG is total generation must be equal to total load plus losses, if any, because losses is also a load. It is very important, but the load is very naughty fellow. It is a random variable. I am sure you must have learned enough mathematics to understand there is something called probability theory, statistics. The Populus is the best book on random variables. I do not know whether you have done that course in mathematics. If not, you can read that book if you have time. The load is a random variable. When you will feel hot enough to start a fan, cooler or AC, nobody knows. Each person will behave in a different way. When you will say, oh stop, it is enough cold, this air conditioning is too much, reduce it. So, each person is free to feel hot enough or cold enough to start a fan or a heater or a fridge or AC or whatever. So, it is a random variable, it varies randomly. I do not know how many of you know normal distribution or Gaussian distribution, which is this, varying from minus 3 sigma to plus 3 sigma. How many of you know? Are you aware of this figure? Some of you, yes. This is the normal or a Gaussian distribution. The beauty of this distribution is it gets completely described by first two moments, namely expectation, expected value or mean value, and second is standard variation or variance, sigma square. Sigma is standard variation. Variance, sigma square is variance. So, you have to forecast the load, you have to keep load variation in mind. Hence, there is a figure drawn here which is called a typical load curve. This is forecasted by energy control center. The idea of energy control center was given for the first time in the world by a fellow called D. Liaco. He gave for the first time. What is energy control center? The energy control center in Delhi is in Katwara Sarai. So, please ask your energy forum person or MTech coordinator to arrange a visit which is across the road. You can in fact walk and see what is happening there. That controls, first monitors and then controls the electric power system in a real time, online monitoring and control. How many of you have heard of SCADA? Supervisory control and data acquisition system, that is SCADA. We have just purchased equipment with 7 lakhs in our downstairs power system lab. You can go there and have a look at it. Now, this particular curve, y axis is megawatt and x axis is time. If it is 24 hours, it is a daily load curve. If it is 7 days, weekly load curve, 30 days, monthly load curve, 12 months, yearly load curve, and so on. Here I have shown a daily load curve. As you can see, load is constantly varying and the peak load comes at a particular time . This is a peak load, this is a time varying load, and this is the base load. This much load is there all the time. Now, you get scholarship, let us say it is 5,000 rupees or whatever amount it is. You have to plan how do you spend that. There is a certain basic expenses, you can't avoid it, fees, some books, the mess dues, the electricity bill, whatever way they get cut, they get added into mess bill or whatever way, that you can't say that you will avoid it, you can't postpone that. But certain expenses are varying, visit to some picture hall or restaurant, you can avoid, you can postpone, you can forget about it. There is a peak, unfortunately you get sick, or brother's marriage, sister's marriage, you have to go home with some gift, that is a peak. Suddenly, it is not, it won't come every time. But power station has to cater to this peak load. That is the job of electric system engineer, to provide electric power. They are obligated, it is an obligation on them to provide power as and when asked. So, your capacity of your power plant will be guided by peak load. and the average load will give you energy consumption. You have just seen the typical load curve, peak load, time of occurrence. Let us define a load factor, which is a very important factor in power system or electric energy system, whatever you want to call it. Average load upon maximum of peak load is the definition of load factor. And naturally, as anybody can see it with even ordinary intelligence, this factor has to be less than 1. At the most it will be 1 when your maximum load and average load are same. That is a step function which you must have learned in your control systems. That is, the load is same throughout, then load factor is 1, but it is not normally so. Load factor is 0.6 or something like that. Your aim, your endeavor, your effort should be make load factor as close to 1 as possible. Why? Can anybody reply this question? Why load factor should be as close to 1 as possible? So that you can use your installed capacity to the maximum. Why a director or a principal of a college asks his heads of department the utility factor? How many people visit library? How many people visit lab and use that particular equipment which is so costly? If it is to be used once in 10 years, why have it? So, the load factor should be made as close to 1 as possible. How do you do that? This itself is a PhD topic. People have written papers and papers in this topic. You must go to library and read papers from the journals of your liking, of your choice. If you are electrical engineer, read IEEE transactions, proceedings IEEE UK, IEEE is US, our own Indian journal, Institution of Engineers. Then there are various journals. You can go to library and get yourself familiarized with those journals. Try to read, develop reading of journals, habit of reading journals. It will help you while doing your project. You may like to do PhD later on. You may like to join R&D organization. We don't know what you want to do, so this will be helpful. Average load gives you energy consumption, as I said, and peak load gives you plant capacity. So, while planning the power plants, you need to survey that particular zone area to which that plant is going to cater to the load. Another important factor is diversity factor. What is diversity? You must have heard this word diversity, unity in diversity. In your house, you don't keep all the bulbs, all the fans, all the ACs, all the coolers on all the time, but you do have them. In case you shift from dining room to bedroom, bedroom to drawing room to study room, you go on starting that particular bulb, particular fan, particular tube, and so on. So, summation of individual maximum demands upon maximum load on the system is always more than 1, because you are not going to have all maximum demands on all the time. At a given point of time, maximum load on the system will be much less. Maybe only 2 tube lights are on, maybe only 2 fans are on, but you may have 10 fans. Even in your classroom, there may be 4 fans, but if it is an MTech class, only first 2 fans are on where you are sitting in first 2 tables or benches or chairs and tables. Why should you keep those fans on which are not going to serve any purpose? It will be a wastage of energy which you can't afford. Higher this factor, better it is. Okay? That means you are conserving energy. Higher factor will only show that you are not using all connected load, you are conserving energy, you are avoiding wastages. How do you achieve this high diversity factor? Having said that you must have a higher diversity factor, that means there should be ways and means to increase it. There are 5 golden rules written here, and fortunately none of them cost you a penny, because whatever scheme you take to your boss, he will say how much money is involved in it. Say if you want to go and attend a conference, your head of department will immediately ask you, fine, you are going for a conference, but how much money you want from me? Or you take any proposal, the first question which any superior or a boss will ask you is, even your parent will ask you, I want to go for some, okay, but how much money you want? Next question will immediately this. None of them needs money. So, there are 5, and yet unfortunately the irony is we do not follow it. India being a poor country, we understand that you may not be able to follow measures which need money. Unfortunately none of them needs money, and it is not that our bosses, the political people, do not know about them. That is a bigger irony, when you know a thing and yet you are not able to do it. Let us start one by one. Incentives to users for using electricity in light load periods, night periods. All of you know in night time not many industries operate, only those industries which are having 3 shifts will operate in night. Normally they will have off. Not many educational institutions will be having classes in night time. Agriculturists, not many will like to irrigate their land in night time, but if a utility tells them, look, if you use power in night time, I will charge only half the money. So, there is an incentive to shift that peak load to elsewhere. Peak shaving techniques, reduce that peak, so that your load factor goes up. You must be knowing that Air India gives you half a price a ticket from Bombay to Delhi if you travel in midnight or 2 a.m. Why? The plane is coming from London and some people have got down in Bombay. So, those seats are available to Delhi, because ultimately plane is going to come to Delhi. So, they literally ask there those who are interested in going to Delhi by air, half a price. It is a win-win situation. You gain if you are paying, provided you are paying from your pocket. If the company is paying, then you will like to travel in a convenient time. Not only that, you are saving on a air ticket, you are saving on hotel, because you are not going to take a room in a hotel, you are going to sit in that Sahar airport or Shivaji airport or Indira Gandhi airport, pass time and then catch a flight at 2 a.m. So, you are not only saving on the airfare, you are also saving on your hotel accommodation. Daylight saving. What is daylight saving? Does anybody know? In summer days, the days are longer. All of us know when I do not know how many of you get up early, but if you get up early 5 a.m. there is a sunlight in summer, whereas in winter up to 6:30 a.m. no sunlight. So, what you can do? You can follow different timings in summer and winter. You can adjust your clocks, so that though it is 4 p.m. it is showing 5 p.m. So, the time has been advanced. What is the use? Your college is over at 4 p.m. Your shops, your offices, you come out early and there is enough daylight available. You shop, you swim, you play tennis without using electric energy. And that is why England had the first 3 World Cups in their land, by telling others that look, you do not have daylight, we have up to 9 p.m. In fact, if you go to Norway and Sweden, The night is only of 3 hours or 4 hours. The sun is shining at midnight, the country of sun at midnight, and you have to literally have the thick curtains to simulate darkness so that you can get sleep in Norway and Sweden. So why not use it in India? Of course, you have to change your timings, adjust your clocks from 3rd week of October, something else, 3rd week of March, as the whole world does it. Why you don't want to do it? It doesn't cost you anything. People will get accustomed to it. Well, ladies and gentlemen, we will do the remaining things tomorrow. So today what we have done, let's revise, let's recapitulate. In this first introductory lecture, various factors have been defined: load factor and diversity factors. Indian and world energy scenario briefly discussed, and in the next lecture we will discuss about the remaining ways in which we can improve a diversity factor, plus structure of power systems, how the power systems have been built, what is there. So, whatever we have done today, if you have any questions, now there is a time, I would like to answer them if you have any. Anything you have? Want to? Any query, any suggestion, or any point which you have not been clear? As I said, we are following this book, and this is from chapter 1, and you can read it. If you do not have a book, there are copies in Central Library and Centers Library, Department Library. You can read it, or you might have taken notes or whatever. And our first minor, I understand, is on 4th September onwards or something. So, start preparing right from day 1. There is no relaxation here. So, in case there is no question and queries, so we will meet you on Tuesday, the coming Tuesday, same time, same studio, same audience. So, thank you very much.